Okay, hi guys. So in this lecture, we'll be discussing on Gabriel Pthalamide synthesis of 1-degree amine. Okay, and we'll be seeing later on in the lecture Hallward Zelensky reaction as well. Okay, so let's get started with the Gabriel Pthalamide synthesis first. So we have Gabriel, Pthalamide synthesis of 1-degree amine. Okay, so we have, let's say for an example, something like this. Okay, what happens to this substrate when we pass KOH, CS3Br and OH minus in that sequence? So we get something like CS3NH2 plus we get CO2 minus on both the adjacent carbon position in phenyl ring. So let us see the mechanism as to how this happens. So we have first this compound. Okay, next we react okay, so first thing we are passing it in presence of KOH, so naturally OH will take the H atom as H plus and will get N negative, so it would become a very good nucleophile. In the second step we are passing CS3Br, so what will happen is N atom will actually attack on CS3 and will get something like this. Okay, via SN2 mechanism. Okay, good nucleophile will attack on a electrophile. Okay, and then what will happen is, then third we are passing OH minus, or in basic medium this bond would be broken up. Okay, and as a result two hydrogens would be getting attached to this nitrogen atom. Okay, so we'll be getting something like, in acidic medium please remember that OH formed. Okay, so first step OH would be formed, and again this OH would then be converted back into acetate, because it is a carboxylic acid and carboxylate ion will form because carboxylic acid is a strong acid. Okay, so this and this are the two products formed. Okay, let's see another example on the same lines. So we have something, so why do we say that Gabriel Pthalamide synthesis of 1-degree amine? Because in the end 1-degree amine was formed. Okay, again we react it first with KOH, second with pH CH2Br, and third we reacted with, obviously pass some basic medium into the reaction mixture. So what would be the product formed? Obviously we would get something like acetate ions. Okay, and we will also get pH CH2Br. Okay, oh sorry, NH2. Okay, now let's move on to seeing Hallward Zelensky reaction. Hallward Zelensky reaction. It is also called HVZ reaction. Okay, so in HVZ, alpha hydrogen of acid is replaced by halogen. I'm first writing the notes here, then we'll be seeing the reaction and its mechanism. In HVZ, alpha hydrogen of acid is replaced by halogen. Okay, so we have acid, this is the alpha hydrogen of this acid, and when we pass it first with red phosphorus plus Br2, okay, and second with water, what we get is the alpha hydrogen is replaced by the halogen, which means this reaction takes place. So let us understand the mechanism of how it takes place. Okay, so first we have phosphorus. Okay, we pass Br2 with it on it, and we get PBr3. Obviously you can balance the reaction by having 3 and you can have 2 and 3 and 2 here. So the reaction is balanced just for balancing purpose. Okay, second what will happen is, this is the acid which we took. Okay, this PBr3 will actually attack on it, or rather oxygen atom from the PBr3 will attack on it, and as a result we'll be getting something like this. I hope you understand the mechanism behind the scenes. We have PBr3 something like this. Oxygen will attack on the phosphorus atom, and again will form a double bond, thereby releasing one Br, which will actually attach itself with H plus. Okay, and the second time the double bond is formed, this Br minus will go and attack on this carbon atom. Okay, and as a result this bond will be broken up. Okay, so I hope you get the mechanism. And then we are actually also passing Br2, red phosphorus plus Br2. So Br2 would be there in the mixture. So what will happen next is it will undergo tautomerism, and we will have something like this structure. Oh, oops. This is structure with Br here. Okay, now this alkene will act as a nucleophile on Br, which is a electrophile. Okay, one of the Br will be attacked and one of the Br will be set free as Br minus, and we'll get something like CH2 Br with positive charge on this carbon. Okay, and O negative here and Br here. Tautomerism will actually give us OH rather. Okay, so this will get something like OH here. And third, we are actually passing basing medium. Even if you pass the water molecule, what will happen is this will again form a IIT cation with a release of H plus. So we'll get final product as CH3 C double bond O, rather CH2Br, and what will happen next is on reaction with water, first I think we should eliminate the leaving group as Br minus is more stable. So what we'll have is CH2Br double bond, positive charge still there, and because it is leaved, it has leaved the compound, then obviously again water molecule will act as a nucleophile and SN1 reaction will take place, in which we will be getting CH2Br here, C double bond O and OH here. Okay, so this will be the final product formed. Okay, so with this we come to the end of this lecture. In the next lecture we'll be seeing test for phenol. Till then, good luck and goodbye.